This video is about how current location methods lead to poor performing retail networks. The principles of supply and demand are the foundation of location science. They help us understand the relationship between retailer supply and consumer demand, and in this graphic, how equilibrium prices effectively clear the market. But the market isn't always in equilibrium. There are times when retailers set prices too high. This creates a market where the quantity offered by retailers is higher than what is purchased by consumers. Oversupply causes retail stock to build up and often signals that a sale is coming. By lowering the price, sales effectively increase consumer demand so that it equals retailer supply and therefore clears the market. And then the cycle becomes ready to repeat. The problem is that retail supply curve needs to temporarily shift to the right during the sale. That is, retailers end up selling too much of their goods at lower prices. It's a cycle too often caused by overcompetition and a major problem of current location methods. Let's take a look at how this happens for some of the best current methods. There are two basic parts to the analytic process. First, we need supply and demand data, and then we need to model market behavior. Generally, there is no problem with the data. Although the sources are different, they all produce estimates of consumer spend and can also be used with a competitive analysis. The problem is how consumer behavior is modeled. Current location methods limit consumers to buying goods in one trade area at a time. They can't account for the real life complexity of consumers buying across multiple trade areas. For example, let's analyze a real life regional shopping center. Using a geofence, mobile phone data is used to map where visitors live. A circled trade area boundary is then drawn around the points. We can represent this with a simple supply and demand curve. The problem begins when you factor in that consumers predominantly buy over multiple competing and overlapping trade areas. Each layer represents a shopping trip to a competing trade area that is being ignored. This effectively shifts the demand curve to the right, at least on paper. This means that each trade area layer is double counting consumer spend. It falsely makes it look like supply and demand equilibrium is at a higher price than it really is, and that the market can support more competitors. More competitors shifts the supply curve to the right. But when you remove the double counted demand, the actual equilibrium price is lower and the sale price cycle begins. And with that, an over competitive retail cluster trap is born. We evaluated 65 retail categories in Canada and found that 53% of retail suffers in low revenue, over competitive trade areas. And yet 35% of trade areas have no competitors at all, and half of those are excellent opportunities. Neighborhoods offer some of the best new opportunities, well hidden under layers of overlapping trade areas. In fact, retailers presently only have a 50-50 chance of success in neighborhoods using current location methods. In conclusion, current location methods lead to poor performing retail networks because they don't account for consumer purchases across multiple shopping centers. They create low revenue, over competitive retail clusters in some locations and large gaps in opportunities that are effectively hidden in others. In the next video, see how Strata fixes location intelligence.